Hello everyone. Welcome to the solution of LeetCode problem 49 named group anagrams. In this problem, we are given an array of strings and we have to group the anagrams together. And we can return the answer in any order. The definition of the anagram is basically an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, basically using the original letters only once. Anyways, let's understand the first example. In the first example, the given vector has 6 string, which is eat, t, 10, 8, nat, and bet. Here, if we group the anagram together, we will not find any similar anagram for bet. So bet is a single group. Anyways, for the word nat, we can find another word which is tan, and nat and tan, both of them are anagram because both has the same number of characters and exactly same frequency of characters. So we can say that nat and tan are the anagrams. And here, if we see the another word 8, ate, and there are two anagrams also for this word, which is EAT and TEA. Here, in three of these string, A, T, and E, these three characters appear exactly one times, or we can say that the frequency of the characters is exactly equal. So here we can say that 8, T, and eat, these three are the another group of anagram. And similar definition for the example 2 and example 3 also. I hope you understood the example. Now let's move on to the constraint. Here the constraint is the given string length can be in between 1 to 10 to the power 4, and each of the string in the given string vector can be in between 0 to 100. And each character of the string consists of only lowercase English letters. I hope you understood the constraint. Now let's move on to the solution. Here, for the simplicity of the algorithm, we took the first example. The current example has 6 words, which is eat, tea, 10, 8, nat, and bet. Now, at first we add the first string, which is EAT. So currently our temp will contain the value EAT. Now, we have to perform the sorting function over the temporary variable temp. And if we perform the sorting function or EAT, the resulting string will become AET. Here, the key is the value of resultant string after sorting, which is AET. AET. And the value is the temporary variable, which is EAT. Now let's erase the first string. Now our current pointer is in the second string. So our current string is T, which is TEA. And if we perform the sort operation here, the resulting string will become AET. So wait, we have an entry in our map where the key is AET. So we can store TEA into the value. So we can store TEA here. Now for the third string, the string is 10, which is TAN. And if we perform the sorting operation, the string will become A and T. So we have to store A and T as the key of the map. So I am storing A and T here. And we have to store TAN as the value. So TAN is stored here. TAN. Now let's erase the third string and move on to the fourth string. Currently, the fourth string is ATE 8. And if we perform the sorting operation, the 8 will become EAT, which is already presented as the key. So we have to store ATE here. Now let's erase it. Now suppose we are in the fifth string, which is NATNet. NATNet. And if we perform the sorting operation into this string, the NAT will become ANT. But wait, ANT is also presented here as a key. So we have to store NAT here. Yeah. Now finally, we have to erase it again. And we will currently in the last string, which is BAT. And if we perform the sorting operation on BAT, the resultant string will become ABT. So we have to store ABT as the key of the map and BAT as the value of the map. So we have to store BAT here. Now wait, we have solved this problem. And if we consider this first value as one vector, this second value is one vector, and this third value is one vector. And if we output all of these three vectors together, then we will reach the solution of this problem. I hope you understood the solution of this problem. Now let's understand the code. Here, the code is pretty simple. At first, we are given a function group anagram. The input parameter of this function is a vector of string, and we have to return a vector of string. Anyways, inside this function, we have to take a map to store the key value pairs. The key is a string and the value is a list of strings or vector of strings. The name of this map is MP, and for storing the result, we have to again take a vector of string, and the name of this vector is ANS, answer. After that, we have to perform a for loop which iterates through the first string to the last string of our given input. And in each iteration, we have to store our current string in a temporary variable named temp. And we have to sort our current string by using the stl sort function. And after sorting, we have to insert the temporary string into the map, which is mp of s of I dot pushback temp. And after we completed the iteration of this for loop, we have to again iterate through the map again, and we have to store only the value part of the map, which is iterator.second. And after that, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. We have to understand the time and space complexity of this program crucially. Here we can see that the loop iterates through each string in the input vector s, which takes basically order of n time, where n is the number of string. And inside the loop, sorting each string can take big O of k log n times, where k is the length of the longest string in the input vector. And inserting each string into the map basically takes order of 1 time. And finally, you can say that iterating through the map to from the answer vector takes big O of m time, where m is the number of unique sorted strings, which is at most equal to n in the worst case. So we can say that the overall time complexity of this algorithm is big O of n into k log n, where k is the length of the longest string in the input vector. Now let's understand the space complexity. Here, the map MP stores sorted string as key and vector of strings as value. The space required for map is proportional to the number of unique sorted strings, which is at most equal to the number of input strings. So the space complexity of the map is big O of n. And the answer vector answer contains vector of string, which will not exceed the size of the input vector s. So the space complexity of answer is also big O of n in the worst case. And additional space is used for the temporary variable, but they are insignificant compared to the main data structures. Pass. So we can say that overall space complexity of this program is big O of n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.